So, are y'all good? Okay, can we do notes? Because I only have 3 examples to do today. All right, so for the first one, I've got the actual function written up there, and we're going to be doing something called piecewise functions for the next couple of days. Other thing to kind of address, you guys have interim grades that are going to get posted soon. Okay, so you want to make sure that you're kind of happy with where your grades are at, and if you have stuff that's missing, like, we definitely get that done. Man, I forgot to take it before the voice of God yells at me. And remember, test corrections are due on Wednesday. All right, so if you were still planning on doing test corrections for Unit 0, so I gave you guys your Unit 0 test back, like last week. I thought I shared it with you via email.
Yeah, but there wasn't like any kind of writing.
Okay, I'll share the Cami one with you then, because I have one with writing. So there's instructions on how to do test corrections on Google Classroom. One of the biggest things with test corrections is your goal is to kind of look back on it and figure out, like, did you make the same mistake over and over again, like a consistent mistake where it's just one giant misunderstanding? Did you make a bunch of little ones? Like, kind of how did all that work? So you can fix that for the future. Okay? You always do test corrections on a separate sheet of paper because you want to leave your test a pristine example of where your little mind was when you took it. All right? So, we ready for some piecewise functions? All right. Piecewise functions, essentially Frankenstein functions. Okay? When we're looking at this, we've got this function right here for every x that is less than -1. Okay? So what I tell students to do is to make a table of values in that color for those values. Okay? So you're going to start with -1 for an x. So even though it's less than -1, you still want to have like a value to go there. It'll just be an open circle because it's not equal to. All right. Now, what other values of x should I pick for this? How about -4? All right, is -4 less than -1? Yes, it is. And can I take the square root of it? Also yes. I can also do -9. Okay? Because again, perfect square root. So when I go through, I do this piece by piece by piece. All right? Negative times a negative gives me a positive. So the square root of +1 is just 1. All right? -4 gives me a +4. Square root of +4 is a 2. And then square root of 9 is 3. So on your graph, you may not have enough room to go all the way to -9, but you can still kind of use that as a guesstimate as to where you're at. All right, so let me scroll a little bit. So I've got -1 for x, +1 for y. Now, you need to put an open circle there because it is less than -1, not equal to. All right, my next point is going to be at -4, +2. And then -9, +3. So I've got a graph that goes like that. All right, and I think with your graphs, the x's go by 1s out to like 6. So you could always just like count 3 over and keep going. All right, what color do we want to do for the middle one? Orange? Okay, we'll go green. I just did blue. All right, we'll do green for this one. We'll do pink for the next one. So what kind of values should I pick for this table? I'm recording. But yes, we are giant children. All right, so what x value should I pick? Guys, look at the restrictions on that middle one. Bam. -1. What else? -1, 0. I should definitely stop at 3. We can go. Now, we could do 1. 2 is going to be a little hard just because we have to do the square root of 2, which is like 1.4-ish. That's also going to suck. All right. Now, here's the problem. -1 and any of these negative values, can I take the square root of those? No. So that one actually does not exist yet. Or at least not on this point. Well, i's coming, but I is on a whole different graph. All right, because it's imaginary. All right. 0, what's the square root of 0? All right, 0 plus 3 is 3. Square root of 1 is? 1 plus 3 is 4. All right. Can we do square root of 2 plus 3? Y'all got calculators? No? All right, hang on, I got one. I got it. $4.414. That's after. Square root of 2 is 4. Cap down. And then 3 plus square root of 3 is 4.73. All right. So, 0, 3, dot. All right, and we're going to make sure that's enclosed because that's included in there. All right. 1, 4, 2, 4, 1, 4, and 3, 4.7. All right, now, make sure end to end, those are both enclosed circles. We said last one we wanted to do in pink. But people don't have orange. Sure. All right. 3. Let's just do 4, 5, 7. All right, so I started skipping around a little bit. Now remember, just because we put 3, it's -3 minus 1, and that's -4. We need to make sure that's still an open circle. All right, so 3 all the way down here at -4, open circle. -4 minus 1, -5, -6, -8, blah, blah, blah. -4, -5, 5, -6, 7, -8. And this should be a straight line going on forever and ever and ever down to the little corner. So what do we think? Worst thing we've ever done? I mean, it's just a little tedious, but it does help when you color code. Okay? Now, we're also going to be doing an activity for the next couple of days. So here is another one. Yep. So 1.5's homework and the Angry Penguins activity are both not due until Thursday. So the reason for that is because I took a bunch of transparency sheets and I printed out the Angry Penguins. You guys are basically playing Angry Birds, but with penguins. All right, cool. So we're going to do it again with piecewise functions. The problem is I don't have enough of the transparency sheets for every individual person. So if you guys want to do it with partners, you can do that. If you want to... Plus 4. Yep. Too far. 4 and x are under the square root. You're like, how far does the line go? All right, what colors do we want to do on this one? All right, purple. Go get a purple. I'm going to do orange. I know I have purple pens back there. I don't know. Are there orange pens in there?
No.
I was going to say, I don't think orange came in those packs. Same thing. Do you guys kind of want to try this one on your own?
Yeah.
Okay. Now, before we do this, where are you going to start your tables? 2. All right. And remember, this one's going to be open. And then it's every x that is less than 2. So 1, 0, negative 1. And I'm going to go all the way to negative 4. All right. And these may not all come out pretty, but it's reasonable. 2, 3, 4. Because it's going to be an open circle there. So there are still infinitely many numbers between 1 and 2. So we want to show where it ends. We're just going to do an open circle on it. And then this one's going to be closed. What was square root of 6? And square root of 5 should be like 2, 4. Okay. Now again, on this one, once you go past negative 4, you're going to start dealing with complex numbers, which we haven't gotten to yet. And you can't graph imaginary numbers on the real plane. Okay. So what do we think? Still kind of weird, but not terrible? Okay. Mm-hmm. Okay. Just kidding. Now, on a quiz or a test, I'm not going to give you guys anything quite so gross. It'll be more linear or quadratic, where you can plug it in and have nicer numbers. But I still like showing the icky ones, so you can do them. Ready for the last one? Nope. Okay. Do you need another stamp, or are you good? Okay. No, tomorrow's advisory. Ready? Okay. You can't see yellow.
Black.
All right, I'll let you pick your own colors. We'll go with that. How are you going to put white on white paper, goober? I know. All right, I'm picking this little seafoam green. Yep, x plus 2 quantity squared. There we go. All right, we're going to start it off at -1, and it's every x less than that, and this one is a closed dot. We'll go -2. Oh, wait, I guess I don't need to do all that, but that's okay. So you'll notice I start jumping points. All right, because I can connect dots in between. And then I'm going to go light blue on that one. And we're going to start at -1, and it's open. Now, what are all of the y values going to be for my light blue one? So if I put in 0, it's still 5. If I put in 2, it's still 5. And if I put in 6, it is still 5. It's definitely still 5. Yep, horizontal line. So -1, open circle at 5. -1 plus 2 is +1. +1 squared is still 1. 0 squared is 0. -2 squared is 4. -4 squared is 16. All right, so -1, 1, closed, 2, 0, -4, -4, and then -6, -16. So it's definitely got a curve to it. Sorry, I know I'm in the way. Oh, just kidding. All right. 0, -4, 4. All right, so there's definitely some kind of change that's happening in here. Do you guys have any idea where it is? Give you a hint, it's vertex form. So it's x plus 2 squared plus 0. So my h is at -2, my k is at 0. That's your vertex. All right, so like that. It's a quadratic, so it's a parabola, but it's only part of the parabola. Just blew your mind on a Tuesday morning? That's okay. I've got more stamps.